With over 5 billion gummy candies produced each year, Haribo, the originator of gummy bears, has spent more than a century steadily operating a billion-dollar gummy candy empire. So what has allowed Haribo to remain irreplaceable? It all begins with gelatin, a familiar ingredient, yet one that nearly 90% of gummy candy consumers have never truly considered. Behind every colorful gummy lies a hidden journey that starts with animal skin and bones, transformed through a highly controlled process into the elastic structure that forms the very soul of gummy candy. Built on this foundation, Haribo's modern production lines run almost non-stop, producing millions of candies each day and supplying shelves around the world. In this video, join Agriculture Insight as we dive deep into the complete process behind this legendary candy and uncover how Haribo has secured its position as the king of the gummy world. Now let's begin. Founded in 1920 in Germany, the name Haribo is simply an abbreviation of Hans Riegel Bonn, the creator of this iconic candy. More than a century later, from a small, unknown confectionery workshop in Bonn, Haribo has risen to become the world's largest gummy candy empire, with annual revenue estimated at around 4 billion USD. In Germany, Haribo's homeland, the brand holds over 50% of the gummy candy market. From the elderly to children, generations have quite literally grown up eating Haribo, making it not just a candy, but a part of Germany's consumer memory and cultural identity. Compared to other well-known gummy brands such as Albanese in the United States, Haribo does not chase extreme softness or overly sweet flavors, instead remaining firmly committed to its traditional chewy texture, a choice that has shaped the brand's DNA for more than a century. Haribo's success has never been accidental, but rather the result of decades of meticulous refinement and unwavering consistency in product philosophy. Even the colors of its gummies are designed according to precise logic. Red appears most frequently because it is consumed the fastest, while green, yellow, and other colors exist not merely for visual appeal, but to balance flavor, consumption rhythm, and the overall user experience. Beyond that, Haribo continuously updates flavors, shapes, and production technologies to adapt to the demands of each market. So what about you? When you open a bag of Haribo, which color instinctively draws your attention first? And every journey has a beginning. Right now, let's step into the very first link in Haribo's gummy production chain, the gelatin factory, where the foundation of every gummy candy is formed. Each day, a large-scale gelatin factory receives between 50 and over 100 tons of raw materials, primarily animal skin and bones. Upon arrival, the materials are inspected for quality and separated into appropriate processing lines. Before further treatment, all raw materials are reduced in size through cutting or grinding to increase surface area for the subsequent processing stages. After being cut into smaller pieces, the raw materials are soaked and washed in large water tanks, combined with continuous agitation to remove blood, fat, and surface impurities, while also hydrating and softening the collagen structure. This is a crucial pre-treatment step that allows the chemical reactions in later stages to proceed evenly and consistently. In this stage, a large volume of wastewater is generated, containing high levels of organic matter and fats. Therefore, appropriate treatment is required to prevent water pollution and environmental impacts. Next, the materials undergo chemical treatment to break down the collagen structure, typically by soaking in an alkaline lime solution for 5 to 20 days, followed by neutralization with a dilute acid to adjust the pH to around 5-6, preparing them for gelatin extraction. At this stage, the material is heated in water at temperatures of up to around 80 degrees Celsius, allowing collagen to gently hydrolyze and dissolve, releasing gelatin into the solution. This process occurs in multiple cycles, producing a protein-rich gelatin solution that forms the foundation of gummy candy's characteristic elasticity. The raw gelatin solution remains cloudy and contains undissolved particles. To achieve the required purity, it is passed through a multi-stage filtration system with ultrafine ceramic membranes. Under high pressure, microscopic impurities are retained, allowing only purified gelatin to pass through, resulting in a clear, uniform, and stable solution. After filtration, the gelatin is demineralized through an ion exchange system, helping to stabilize its pH, color, and gel strength. Subsequently, the gelatin solution is heated to maintain its liquid state and fed into the vacuum concentration system. The concentration process is carried out at a temperature not exceeding 70 degrees Celsius in order to minimize gelatin denaturation, while excess water is removed to increase the solid's content to approximately 30 to 40%. The resulting solution has sufficient viscosity and consistency for subsequent forming and further processing steps. After the gelatin solution is cooled to a semi-solid state, the elastic mass is pressed through perforated metal plates with precisely controlled openings, forming long, continuous gelatin strands. This extrusion is carried out under stable pressure to ensure uniform strand size and structure, which directly affects the gelatin's solubility and gel strength. As the material passes through the plates, the protein structure begins to set, transitioning from a bulk mass into flexible strands. The strands then fall onto a conveyor belt and are dried with sterile hot air, removing most of the moisture while preserving the protein structure that gives gummy candy its characteristic elasticity. After drying, the gelatin is ground into a fine, uniform powder for easy dissolution and precise dosing. From here, the gelatin is bagged and sealed by batch, ready for immediate shipment to food manufacturing facilities worldwide, as delays and exposure to moisture or temperature fluctuations can reduce solubility and elasticity, directly affecting final product quality. And now, let's move on to the most anticipated part of the journey, where gelatin is no longer just a raw protein powder, but is activated on Haribo's production lines, transforming into millions of chewy gummy candies found on shelves around the world. At Haribo factories, the candy production process begins with the careful selection and precise weighing of key ingredients, such as gelatin, sugar, glucose syrup, water, food acids, flavorings, and colorants. These ingredients are then fed into the mixing system according to pre-programmed formulations, strictly adhering to Haribo's proprietary recipes. From the very first stage, each batch is closely monitored to ensure absolute uniformity and consistent quality across millions of finished candies. After dosing is complete, the mixture is transferred to industrial cooking kettles and heated using high-pressure steam. Under controlled heat, water evaporates while sugar and gelatin fully dissolve. Within just a few minutes, the mixture becomes a smooth, uniform liquid syrup, ready for the next stage of structural stabilization. After cooling, the syrup is tested for bricks using a refractometer to ensure the sugar concentration and consistency meet the required standards before shaping. At this stage, the base syrup is divided into multiple streams for color and flavor blending according to each product. Haribo produces dozens of different flavors, with sour varieties such as cherry, raspberry, and grape, requiring precise acid control to deliver a sharp taste while maintaining gelatin stability. In parallel with flavor preparation, molds are formed directly on the mogul machine using cornstarch blended with mineral oil. The machine spreads and levels the starch, after which stamping heads press the candy shapes into the starch bed, creating hundreds of soft cavities on each tray. The cornstarch not only holds the shape of the candies, but also absorbs moisture from the hot candy mass, allowing it to set slowly and uniformly, an essential factor in developing the characteristic chewy and elastic texture. When the starch molds are ready, the gummy syrup is transferred into central depositing hoppers, where temperature and viscosity are tightly controlled to ensure precise flow. An automated depositing system then dispenses exact amounts into each mold cavity with minimal deviation. Throughout the process, sensors monitor syrup temperature and flow to prevent underfilling, overfilling, or air entrapment, allowing Haribo to maintain consistent gummy quality even at massive industrial scale. After depositing, the trays are stacked and moved into curing rooms for approximately 18 to 24 hours. During this time, the cornstarch continues to absorb excess moisture while the gelatin fully sets, forming a stable, chewy, and elastic structure. After the curing stage, the trays are inverted over vibrating screens, allowing the gummy candies to separate from the starch molds and continue along the production line. The remaining cornstarch falls into a recovery system, where it is cleaned and reused for subsequent batches, improving overall production efficiency. The gummies are then transferred into slow-rotating drums, where they gently tumble and collide with one another as the drums turn. This motion removes any remaining starch residue from the surface, while rounding the edges and evening out the shape of each candy. Once cleaned, a thin polishing layer made from vegetable oil, combined with beeswax or carnauba wax, is evenly applied inside the rotating drums. This coating prevents sticking, enhances surface smoothness, preserves color, and gives the gummies their familiar dry, pleasant feel. A small detail that plays a key role in the signature Haribo eating experience. Finished gummies are randomly sampled and inspected for shape, color consistency, flavor, and chewiness to ensure each batch meets Haribo's standards. Selected samples undergo additional testing for elasticity and heat resistance, confirming that the gummies maintain their characteristic texture and stability during storage and distribution. Only products that pass all checks proceed to packaging. Finally, gummies that meet quality standards are fed directly from the conveyor into a fully automated packaging system, where multi-head weighing hoppers continuously portion the candies according to precisely preset weights. Each hopper calculates the optimal combination in real time, then releases its measured load straight into individual bags in a split second, ensuring uniform fill levels and minimal variation even at extremely high production speeds. Once filled, the bags are immediately heat-sealed, labeled, and passed through metal detectors to eliminate any risk of contamination. They are then packed into cartons, shrink-wrapped, and stacked onto pallets, ready to enter Haribo's global logistics network. This seamless, end-to-end automated process enables millions of Haribo products to leave the factory every day, supplying retail shelves across hundreds of countries worldwide. Notably, every Haribo gummy is engineered to deliver a chew time of approximately 20 to 30 seconds, significantly longer than fast-melting candies. This extended chewing gradually releases sugar and flavor, creating a smoother sweetness, less taste fatigue, and a consistently satisfying eating experience, no matter where in the world the candy is enjoyed. The story of Snickers began in 1930, when Frank C. Mars, founder of Mars Incorporated, created the perfect combination of soft nougat, chewy caramel, crunchy peanuts, and creamy milk chocolate. Launched at just 5 cents during the Great Depression, Snickers quickly became a favorite. Today, it generates over $2 billion in annual revenue across 6 continents, making it one of the best-selling candy bars of all time. Mars sources high-quality cacao beans from regions like Ghana and Ivory Coast, known for their rich, flavorful cocoa. Stay tuned as we uncover the fascinating process behind every Snickers bar. Let's kick off this journey by diving into how the iconic milk chocolate coating is made, one of the key ingredients that delivers its signature sweet, creamy flavor. The chocolate coating is what gives Snickers its mouth-watering allure, and creating it is an art form. First, cocoa beans are roasted at temperatures between 120 degrees Celsius and 140 degrees Celsius for about 30 to 40 minutes, ensuring that their rich, bold flavor is preserved. The roasting process is carefully controlled to bring out the deep, aromatic notes of the cocoa. After roasting, the beans are cracked open, leaving only the cocoa nibs, which are finely ground into chocolate liquor. After being stripped of their shells, cacao nibs are finely ground into a rich, velvety paste known as cacao mass. Under steady grinding pressure, the nibs gradually melt, releasing their luscious cacao butter. A thick mixture containing cocoa butter. This liquor is the heart of the chocolate, giving it the smooth texture we love. Next, the chocolate liquor undergoes a conching process that lasts anywhere from 12 to 72 hours. This continuous mixing and grinding process gives the chocolate its velvety, smooth texture and eliminates any bitter, volatile impurities. The conching process is key in ensuring the chocolate achieves the perfect consistency and flavor. To create the signature milk chocolate, cocoa butter is combined with sugar, milk powder, and natural vanilla extract, resulting in the characteristic sweet and creamy taste that makes Snickers so irresistible. After the chocolate is blended and finely ground, conching, it goes through a tempering process to ensure a beautiful glossy finish and prevent it from melting too quickly when held. This step involves 3 stages. First, the chocolate is heated to 45 degrees C to 50 degrees Celsius to fully melt. Then, it's cooled down to about 27 degrees Celsius to form stable cocoa butter crystals. Finally, it is gently reheated to 30 degrees Celsius, 30 degrees Celsius to maintain its smooth, liquid state. Thanks to this tempering process, Snickers' chocolate coating is not only glossy and crisp when bitten into, but also melts smoothly in your mouth. Lastly, the chocolate is kept at a temperature of around 45 degrees Celsius to maintain its smooth, melt-in-your-mouth texture before being coated onto the Snickers bar. This process ensures that each candy bar has the perfect amount of glossy, smooth chocolate, not too thick, not too thin, that pairs beautifully with the soft nougat, chewy caramel, and crunchy peanuts. Above the nougat lies the chewy caramel, a delectable layer that stretches irresistibly with every bite. Creating caramel involves heating sugar, glucose syrup, and fresh milk until the mixture reaches a golden brown hue. This step typically requires temperatures between 160 degrees and 170 degrees. Caramel making is both an art and a science, requiring precise control over time and temperature to achieve the perfect consistency. What makes Snickers caramel unique is its extended cooking time, enhancing its rich, buttery taste and perfect chewy texture. This specialized technique ensures the caramel remains soft while providing a satisfying stretch when you take a bite. The balance between firmness and elasticity ensures the caramel does not become too sticky or hard, maintaining the pleasurable mouthfeel of each Snickers bar. To maintain product uniformity, Mars uses state-of-the-art equipment to monitor and control the caramel making process. This automation guarantees the precise caramel thickness in every Snickers bar, ensuring consistent quality across millions of units. But don't forget, aside from the gooey caramel, there's another key ingredient that gives Snickers its signature flavor and irresistible crunch: those perfectly roasted, crunchy peanuts. Did you know that every day, Mars requires enough peanuts to cover more than 54 football fields just to make Snickers? From rough, humble-looking peanuts still wrapped in their rugged shells, an impressive transformation begins. They are first passed through a high-pressure air and screening system, where dust, sand, and debris are thoroughly removed. Only peanuts that meet strict standards for size, moisture, and color are selected to move forward on this flavorful journey. Next, the peanuts are sent into a modern shelling machine that uses a gentle rolling or tapping mechanism to crack the outer shells without damaging the golden kernels inside. Immediately afterward, a strong blast of air whisks away the loosened shells, leaving behind clean, whole peanuts. But we're not done yet. Before any roasting happens, the peanuts pass through a skinning machine, where soft, rotating brushes gently remove the thin, reddish skins clinging to the kernels. This delicate step ensures that only the smooth, flawless cores remain for the next stage. Can you smell that? That rich, nutty aroma drifting through the air means the giant industrial roasters have kicked into gear. The peanut kernels are roasted evenly at 320 to 356 degrees Fahrenheit, 160 to 180 degrees Celsius, for about 20 to 30 minutes, with the rotating drums ensuring that each peanut turns perfectly golden, crunchy, and never overcooked. Caramel and peanuts. A seemingly simple combination, but one that requires meticulous precision and expertise to achieve absolute perfection. Can you guess how they mix them to create the ideal, mouth-watering flavor? When the caramel reaches its perfect, velvety consistency and remains warm, around 120 degrees Celsius, the perfectly roasted, golden brown peanuts are evenly spread through automated conveyor systems, ensuring that each candy bar has a consistent and balanced amount. The peanuts not only add a rich, nutty flavor, but also provide a satisfying crunch, which contrasts beautifully with the smooth, soft, and chewy caramel. If chocolate is the elegant outer shell, then nougat is the heart of a Snickers bar. Soft, airy, yet undeniably strong, it provides the perfect foundation, balancing the textures and flavors of caramel, peanuts, and chocolate. Nougat forms the light, fluffy, and mildly sweet base layer of Snickers. To create it, glucose syrup and sugar are heated to around 150 degrees. Meanwhile, egg whites are whipped at high speed until they become a smooth, airy mixture. The hot syrup is then gradually poured in while continuing to whip, giving the nougat its signature light, chewy texture. This process requires absolute precision. If the mixture is too hot, the nougat turns hard. If too cool, it becomes overly soft. Achieving the perfect balance ensures it complements the caramel and peanuts layered above. Next time you bite into a Snickers, take a moment to appreciate the magic. Who knew science and sweetness could blend so perfectly? Once the nougat has cooled to the perfect temperature, a rich dose of peanut butter is introduced, enhancing its creamy texture and signature nutty flavor. And when the nougat is ready, a rich layer of warm peanut caramel is poured over it, creating a smooth, glossy coating. Crispy, nutty peanuts blend perfectly into the caramel, offering a delightful mix of chewy and crunchy textures. The large candy sheets formed from nougat and caramel, mixed with peanuts, are then transferred to the specialized cutting area. Each bar is cut to precise dimensions, typically 10 centimeters by 2.5 centimeters for the classic Snickers. An automatic cutter divides the candy sheet into 38 evenly sized strips. Then, another cutter slices these strips horizontally, creating perfectly sized individual Snickers bars. Next, the freshly cut bars enter the chocolate enrobing stage, where they receive their signature coating. The uncovered Snickers bars first pass through the bottom enrober, where a layer of milk chocolate coats the underside for an even base. They then move through the full enrober, where a continuous chocolate flow fully covers each bar. To ensure uniformity, excess chocolate is removed using vibration and air-blowing mechanisms. The chocolate is precisely tempered with pure cocoa butter, maintaining the ideal consistency for a smooth, crack-free coating. Once coated, the bars travel along a conveyor, allowing the chocolate to settle before the next production stage. A finishing touch makes each Snickers instantly recognizable, the elegant swirl of chocolate on top. Once perfected, the bars enter a rapid cooling system, where the chocolate hardens to lock in its flawless shape, ensuring the ultimate Snickers experience before packaging. Each Snickers bar is not only a perfect blend of cocoa, peanuts, caramel, and nougat, but also undergoes a rigorous quality control process. Advanced scanners and sensors detect even the smallest defects, from uneven shapes to cracks in the chocolate, ensuring only the most perfect bars reach the consumer. The finished Snickers bars are moved to the automated packaging area, where each bar is carefully wrapped in its signature, elegant packaging. With its unmistakable design and an inner foil layer, every Snickers bar is protected to maintain its freshness and distinctive flavor. The packaging process is carried out by automated machines, capable of wrapping up to 800 bars per minute, ensuring a rapid production speed while maintaining perfect precision, delivering flawless products to the consumers. The large Snickers cartons are then transported to distribution points, ensuring they reach store shelves across the globe, ready to deliver their signature taste to consumers everywhere. Although Snickers remains a top seller worldwide, Mars continues to innovate with new versions of this iconic candy bar. From familiar sizes to variations like Snickers Almond and Snickers Dark, each version offers a unique, indulgent experience to satisfy every taste. Born in 1964, from the idea of reusing leftover tortillas at a restaurant in Disneyland, Doritos quickly became a global icon of corn-based snacks, made from an ingredient more associated with Mexican cuisine than the food industry. With over $4 billion in annual revenue, Doritos is the best-selling corn snack in the world, available in more than 70 countries. In the US alone, it holds nearly 20% of the savory snack market. Second to Lay's in volume, yet leading in bold flavor and strong personality. Unlike light and airy potato chips, Doritos are crispy and dense, coated in charred cheese flavor with a hint of smoky roasted corn, delivering a heavy hit of taste from the very first bite. However, just half a bag of Doritos contains nearly 40% of the recommended daily sodium intake, about 3 times that of a regular serving of potato chips. Doritos has not only shaped global snacking trends, but also revealed the fine line between health and our dependence on flavor. So, how many bags of Doritos could you eat in a year? Before becoming the crispy golden chips inside every bag of Doritos, each corn plant goes through more than 4 months of meticulous care, from the moment the seeds are sown until the ears fully mature. Then, as autumn arrives, vast cornfields stretching for hundreds of hectares awaken to the thunderous roar of giant combine harvesters working tirelessly day and night. These machines are truly the heart of modern harvest season. Equipped with ultra-sharp stainless steel blades, they can automatically adjust their cutting height according to the terrain and plant size, ensuring precise cuts at the ears without damaging the stalks or losing kernels. Once cut, the corn ears are drawn into a sealed processing chamber, where gears, air blowers, and vibrating sieves work in perfect harmony to remove husks, silks, and stems, leaving each ear in its optimal condition. Immediately after harvesting, the corn is unloaded directly onto specialized trucks and transported to the factory in the shortest possible time. Thanks to modern technology, each harvester can process up to 140 tons of corn per day, drastically shortening the harvest period while preserving the freshness, sweetness, and natural starch content of every kernel. These qualities form the foundation of the smooth, elastic masa dough that gives Doritos their signature golden crunch. After leaving the fields, trucks loaded with golden corn ears line up and head toward the factory. Each massive truck bed is tilted to pour the corn onto outdoor conveyor systems, where thousands of tons of raw material begin their next journey. The entire area operates like one giant machine. Bulldozers, conveyors, and air blowers working non-stop to evenly distribute the corn and keep the flow of material smooth and uninterrupted. From here, the corn is sent into the processing zone, ready for the next magical transformation, from raw kernels into soft, elastic masa dough, the very foundation of the legendary Doritos snack. As the corn travels along the conveyor belt, its first journey inside the factory officially begins. Each ear of corn passes through a high-speed husking system, where rough-surfaced rollers spin thousands of times per minute. Within seconds, the dry husks and silks are completely removed, without scratching or cracking a single kernel. Immediately after, the corn enters the kernel separation chamber, one of the most crucial stages of the process. Inside, 6 ultra-sharp steel blades operate in perfect synchronization at high speed, slicing the kernels off the cob with such precision that almost none are lost. Smart sensors automatically adjust the spacing between the blades, ensuring flawless performance regardless of the size of each ear. This production line can handle up to 6,000 ears per hour, creating a mechanical rhythm that's both powerful and precise. Right after the kernels are separated, streams of golden corn are directed straight into the cleaning system. Here, the kernels pass through a series of vibrating sieves, where controlled airflows and rhythmic shaking work together to remove dust, small stones, and fine sand. Then, they are thoroughly washed in high-pressure swirling water tanks, leaving each kernel gleaming and pristine as if freshly awakened. Next, the corn enters a specialized rotating drum that peels off the outer layer while removing any kernels that are too small, too large, or broken. This step ensures even cooking and lays the foundation for producing high-quality masa dough. Once cleaned and meeting quality standards, the corn is directed straight to the cooking area, where the real transformation begins. Giant mixing kettles cook the corn at around 190 degrees Fahrenheit, 88 degrees Celsius, for about 4 minutes, with a ratio of 660 pounds of corn to 20 pounds of water in each batch. This softens the kernels and breaks down their internal structure. The cooked corn is then transferred to 18 open soaking tanks, where it continues to absorb water for several hours until reaching the ideal moisture level. After soaking, the softened outer skins float to the surface and are removed, leaving only the pure kernels. The corn stream is then directed into an automated washing system, where high-pressure water jets and swirling tanks continuously clean and flush away any remaining husks or impurities. What's left are moist, smooth, and gleaming kernels, perfectly prepared for the grinding stage, where they will be transformed into a uniform, refined masa dough. The corn then enters the grinding stage, where it's crushed between 2 rotating alumina stones. At this point, about 20% white corn is often added to improve cohesion and create a smoother texture. Here, 3 key parameters are strictly monitored: temperature, moisture, and fineness of the dough. Even a deviation of just 1% in any of these factors can ruin the masa's life, its elasticity, and its ability to form that perfect crisp and airy texture after frying. From this masa, every Doritos chip is born with the same DNA, a perfectly balanced dough formula that Frito-Lay has kept secret for decades. Continuing down the production line, the perfectly prepared masa is pressed through metal rollers to form thin sheets, which then pass through a triangular cutter, capable of slicing up to 6,000 pieces per minute or more than 8 million chips per day. Immediately after, the small dough pieces are baked in a 3-tier high-temperature oven for 16 seconds. Just enough time to dry the surface while keeping the core slightly moist, ensuring the chips remain flexible yet structurally intact. This process is what creates the tiny air bubbles on the surface of Doritos, the hallmark of that perfectly crisp, signature texture fans love. To achieve the perfect crispness without burning, the cut chips are fried precisely for 55 seconds. During this time, the air bubbles expand one last time, creating that light, airy, and irresistibly crunchy texture. As soon as they emerge from the oil, the chips are drained of any excess oil and prepared for the seasoning stage, where the true soul of Doritos awakens, giving them their unmistakable flavor that sets them apart from every other snack out there. Before seasoning, Doritos chips are lightly sprayed with canola oil to help the coating stick, then sent into a massive rotating drum, where cheddar, parmesan, and a blend of spices are evenly dusted over each chip as they tumble gently against one another without breaking. In that moment, the rich, creamy cheese blends perfectly with the corn's natural sweetness, creating the bold, crispy, and irresistibly addictive flavor that defines Doritos. From this iconic base, the brand has expanded to more than 20 different flavors, from fiery barbecue to versions inspired by Mexican street food, transforming Doritos into a global symbol of creativity and bold taste. And after all those transformations, the Doritos journey inside the factory comes to an end on the cooling conveyor, where a burst of cold air quickly locks out moisture to seal in that signature crunch. At the packaging area, fully automated 14-head weighers ensure each bag reaches the exact target weight, with smaller bags holding around 28 to 30 chips and larger ones about 140. Before being sealed, nitrogen gas is pumped into every bag, not only to remove oxygen and keep the chips crisp for longer, but also to create a cushion of air that protects each piece from breaking during transport. From here, Doritos leave the factory floor and blend into everyday life, appearing on dining tables, in snack bags, and home kitchens, inspiring endless culinary creativity. In Mexico, Dorlocos is a famously crazy street food, with Doritos as its soul. Crispy, cheese-coated chips mixed with vegetables, candy, lime, chili, and pork rinds, creating a bold symphony of spicy, tangy, sweet, salty, and rich flavors. For just 30 to 50 pesos, you can taste the vibrant spirit of Mexican street food. And behind every crunchy bite lies a story of fusion between Mexican craftsmanship and American technology, where tradition is reborn as a global snack icon. In June, across the states of Kansas, the wheat capitals of the United States, endless fields turn a brilliant shade of gold under the summer sun. It's a familiar signal. Harvest season has begun. Right then, the massive combine harvesters begin to roll. Each one stands nearly 3 meters tall, stretches over 10 meters long, so massive that anyone standing beside it looks completely dwarfed by the steel giant. Small in size perhaps, but still in full command of the entire harvest. At the front, a sharp cutting blade glides just above the ground, neatly drawing whole stalks into the machine. The leftover straw is returned to the field like a natural mulch, while the clean kernels are collected into an onboard storage tank. Each modern harvester can collect over 90 tons of wheat per hour, an astonishing figure, equal to the labor of hundreds of workers operating non-stop, leaving behind the bulky, complicated machines of the past that once dominated the fields. These days, farmers no longer have to bend over with sickles to harvest each stalk by hand. But that doesn't mean they have it easy. The fields today are more expansive than ever, stretching endlessly to the horizon, so vast that even a bird in flight might never reach the end. To make it more challenging, harvesting can only happen in the early morning or late afternoon, when moisture levels are just right to avoid cracked or damaged grains. That's why lunch often means a cold meal eaten in a hurry under the shade of a harvester, chewing between rows, eyes still watching the field bathed in golden light. Out here, every minute counts, and true rest becomes a rare luxury during harvest season. Then it's right back to the harvest. Grain tank is full, the wheat is unloaded directly into large trucks driving alongside the field, or a specialized truck drives alongside the harvester, receiving a steady stream of wheat pouring from the unloading pipe, all happening seamlessly, without the machine stopping for even a second. This synchronized and precise process helps optimize time, maintain ideal freshness and dryness, and preserve the grain's quality, minimizing post-harvest losses to the greatest extent. After being harvested from vast wheat fields, the grain is transported to a grain storage facility. Here, the wheat is unloaded into underground receiving pits. These are steel-reinforced pits, built directly beneath the receiving area of the facility. From these pits, the wheat is moved by conveyor belts or bucket elevators into large silos, towering cylindrical storage tanks made of steel or concrete. Inside the silos, the wheat is stored under strictly controlled conditions for humidity, temperature, and ventilation. Inside these seemingly empty metal ducts, tons of wheat grains are silently moving, weaving through every bend and corner, making their way to specific areas such as cleaning machines and moisture conditioning units within the factory. After being thoroughly cleaned and resting inside massive silos, wheat begins its next journey, heading to the flour mill. But instead of walking or hopping on a train, the wheat slides through enclosed pipes and industrial chutes. At the end of the slide, tons of golden wheat grains come rushing down into enormous trucks, each capable of carrying 25 to 30 tons, roughly the weight of 5 full-grown elephants. But don't think they can just hit the road right away. Before leaving the site, each truck must pass through an electronic weigh station, ensuring the load is within legal limits and recording the exact weight down to the last kilogram. This strict monitoring isn't just about avoiding overloaded trucks. It's also essential for inventory management and traceability. In the food processing industry, every grain of wheat must have its own identity papers. Inside the flour mill, after undergoing initial cleaning, the wheat grains are passed through an additional round of screening, this time much more meticulous. From the screening section, the grains are sent to a central distribution hopper system, where automated valves precisely control the flow of wheat into the next stages of processing. However, before they can be milled, the grains must go through large tempering tanks. The wheat is lightly moistened and left to rest for 12 to 24 hours. This softens the outer bran layer, making it easier to separate during milling. Next comes what's often referred to as the heart of the factory, a long line of modern roller mills. In modern factories, a single production line can include 20 to 40 machines like this, each responsible for a different stage of grinding, from coarse to intermediate to fine milling. This setup maximizes both efficiency and flour quality, especially for specialty flours like pizza flour. Each pair of steel rollers spins steadily, crushing the wheat kernels and gently separating the bran, the germ, and the bright white endosperm inside. It's this endosperm, rich in starch and protein, that becomes the smooth white flour, the very foundation of a perfect pizza crust. After milling, the flour isn't ready for packaging just yet. You think those machines bouncing up and down like they've had one too many espressos? They're not dancing for fun. They're plan sifters, the unsung heroes making sure your pizza flour is smoother than your best pickup line. A large rectangular machine suspended by flexible rods, containing multiple layers of fine mesh screens. The machine gently vibrates, allowing the flour to be sorted by size with micron-level precision. Flour that meets the standard moves forward, while coarser particles are sent back for regrinding. This is the final and most critical sifting stage, ensuring pizza flour comes out consistently fine and high quality. Because with pizza, even the tiniest inconsistency can throw off the perfect crust. Next, the fine flour is transported through a high-pressure pneumatic system. Think of it as a high-speed expressway just for flour. It's carried to a cyclone separator, where centrifugal force separates the flour from the airstream, allowing for clean, dust-free, and lossless recovery. And those tangled stainless steel pipes that look like a maze? They're part of the system that delivers flour to the blending station. Here, the fine flour is given its final adjustments. Depending on the end product, enzymes, malt flour, or B vitamins may be added. Finally, after passing the last quality check for fineness and fluffiness, the flour is sent to the automated packing area. Here, every stream of fine flour is precisely weighed, filled into pre-labeled bags, and tightly sealed to preserve its freshness. Each bag typically weighs around 25 kilograms, just the right size for bakeries and food factories. Robotic arms carefully lift each bag of flour one by one, smoothly rotating and placing them neatly onto waiting pallets. The finished flour bags are then neatly stacked in climate-controlled storage, where both temperature and humidity are carefully monitored. And just like that, every pizza crust begins with a journey this meticulous. And now comes the moment we've all been waiting for. Don't forget, we're still on a journey to create the perfect pizza. It all begins with the crispy, chewy crust, the foundation that can make or break a great pizza. Once the dough has rested long enough, it's divided into long strips and passed through rollers. Next, the dough enters the shaping and cutting stage, where circular, square, or oval cutters form each base precisely. Have you ever noticed those tiny little holes on a pizza crust? They look like someone gently poked the dough with a fork. Those holes actually help steam escape during baking, preventing the crust from puffing up or cracking. And this is where the real differences begin to show. If the croissant is a symphony of butter and layers, pizza is a playground of tomato sauce, cheese, and whatever flavors your heart desires. At this stage, the pizza crust is partially baked to set its structure, lightly dry the surface, and prevent the tomato sauce from soaking into the dough later on. Next, the tomato sauce is gently spread across the crust. This special sauce is made from ripe, juicy tomatoes blended with garlic, oregano, basil, and a touch of olive oil, creating a rich, slightly sweet, and aromatic flavor that defines a classic pizza. The automatic cheese applicator operates with absolute precision. It uses fresh mozzarella, a cheese famous for its smooth melt, glossy finish, and rich texture that stays soft without releasing excess moisture. This is the secret weapon behind the irresistible appeal of every pizza. The amount of cheese is pre-measured according to specific recipes, depending on the pizza type, from classic to premium, to ensure the perfect stretch and deliciously melty richness when baked. Next, toppings like pepperoni, sausage, or bacon are automatically distributed over the freshly layered cheese. Slices of bright red pepperoni are neatly arranged, creating a visually appealing pattern and ensuring every bite is packed with rich, savory flavor. Before packaging, each pizza takes a quick trip through a gentle heating tunnel, like a mini spa session where the cheese melts just enough to hug the toppings tightly. This helps lock everything in place so nothing slides around during transport. Even better, the heat gives the surface a light sterilization, keeping the pizza fresh and safe for longer. After exiting the heating tunnel, the pizzas are moved to the packaging area. First, each pizza is tightly wrapped in plastic film to preserve freshness and maintain its shape during transport. Then, it's placed into a tray or box, labeled with product information and expiry date, and sent to cold storage for preservation before distribution. After that, the pizzas are transported to supermarkets, convenience stores, and distribution centers across the country. They are kept in consistently cold conditions throughout the journey to preserve their quality. And just like that, each fresh and delicious pizza is ready to become part of the daily meals of millions of families. If you enjoyed this video, don't forget to like, share, and leave a comment.